Think about that leftover chicken in your fridge. Right now, on its surface, an invisible war is being waged. Food poisoning hits 48 million Americans every year. That is roughly 1 in 6 people. Most cases feel the same. Stomach cramps, a sudden sprint to the bathroom, a night of misery, and then it passes. But very few people know what is actually happening inside their body. It turns out food poisoning is not really about the food itself. It is about a population explosion. At room temperature, a single bacterium on your sandwich can become more than 16 million bacteria in just 8 hours. And your violent reaction is not a malfunction. It is your immune system evicting them as fast as physically possible. Here's how it works. Food poisoning is caused by 3 things: live bacteria, viruses, or toxins that bacteria leave behind. When you eat contaminated food, the pathogens ride into your stomach, survive the acid, and attach to the lining of your small intestine. Some, like Salmonella, invade the cells directly. Others, like Staphylococcus aureus, never even need to be alive when you eat them. They leave behind heat-resistant toxins that can survive cooking. The real danger is how fast they multiply. Most bacteria double every 20 minutes in the temperature range between 40 and 140 degrees Fahrenheit, which scientists call the danger zone. One bacterium becomes 2, then 4, then 8. In 8 hours, that is more than 16 million cells. Your body only needs a few thousand to get sick. There are about 250 known foodborne diseases, but just a handful cause most cases. Salmonella lives on raw chicken and eggs and causes around 1.35 million infections a year in the United States alone. E. coli A157, found in undercooked beef and contaminated leafy greens, produces a toxin that damages blood vessels in the gut. Norovirus, the infamous cruise ship virus, spreads from just a few particles on a surface and causes nearly 60% of all U.S. food poisoning cases. Listeria thrives in the cold, which is why it contaminates deli meats and soft cheeses even in the refrigerator. And Clostridium botulinum, the rarest of the group, produces the most lethal toxin known to biology. 1 gram could theoretically kill 1 million people. All of them share the same trick. They multiply faster than your body can deal with them. Here is the surprising part. The awful symptoms of food poisoning are not the disease. They are the cure. When pathogens trigger the nerves lining your gut, your body launches a coordinated expulsion. Vomiting flushes toxins out through the top. Diarrhea flushes them out through the bottom, pulling water into the intestine to rinse the lining clean. Fever raises your core temperature to make the environment hostile to bacteria. Cramping is caused by your intestines contracting to move everything out faster. Your immune system also releases a burst of prostaglandins, which is why you feel exhausted, weak, and achy. You are not sick because of the bacteria. You are sick because your body is waging a scorched earth campaign to get rid of them. That is also why anti-diarrhea medications can backfire. They trap the pathogens inside you longer. Almost all food poisoning is preventable with 4 simple rules. Keep hot food above 140 degrees Fahrenheit and cold food below 40. That is the line where bacteria stop dividing quickly. Never leave food at room temperature for more than 2 hours, or 1 hour if it is above 90 degrees outside. Cook meat to its safe internal temperature. 165 for chicken, 160 for ground beef, 145 for whole cuts and fish. And wash your hands for 20 seconds, because the most common route of contamination is not the food itself, it is the human handling it. For most healthy adults, food poisoning is miserable but passes in 1 to 3 days with rest and fluids. Children, the elderly, pregnant women, and anyone with a weakened immune system should seek medical attention quickly, because dehydration and systemic infection can become life-threatening in hours. If this changed how you look at that leftover in your fridge, subscribe to Curious Science. Next, we explore why space is so cold.